I built this simple circuit to experiment with feedback. There is an op-amp in inverting configuration, gain of 10, and power stage made of a pair of transistors, one NPN and one PNP. The op-amp model is not critical. For breadboarding I'm using TL081 from Texas Instruments. Here is a real circuit built on a breadboard. I connected two probes to the circuit, one to the output of the op-amp and another to the output of the power stage. Both probes go to this little bitscope USB oscilloscope, and we are going to see its screen in a minute. The input of the circuit is connected to the function generator, 100 Hz, 100 millivolts. Let's now see the traces. Let's make it bigger. Okay, the yellow trace is op-amp output. The green trace is power stage output. We can see it's not quite sinusoidal, and the horizontal part of the trace is what's called a crossover distortion. When input voltage is between minus 0.65 volts and plus 0.65 volts, both transistors are closed. Crossover distortion is bad and we want to eliminate it, but let's first model this circuit in LT-Spice. Here's the LT-Spice model. This is my generator, 100 millivolts, 100 Hz. This is the op-amp, the pair of transistors, the load, and two power supplies, plus and minus 15 volts. Let's run the simulation and watch the waveforms. This is op-amp output and this is power stage output, and we can see it's pretty close to the real one. Now let's think about how to fix the output. We remember that negative feedback in electronics was invented by Harold Black to make linear circuits using non-linear devices. In my circuit, a feedback is not doing anything except for maintaining gain. As we can see, the output of an op-amp reproduces an input sine wave quite well. Let's change our model to include the power stage into feedback loop and see what happens. Let's run the simulation again. See, that's the output. Now the distortion is gone, and that's an output of an op-amp. We can see how it tries to compensate. Now let's go and modify the real one just to see what happens. I'm going to go ahead and move the resistor on the breadboard from op-amp output to the power stage output, and let's see what happens. So I pulled it and I connected it, and we can now see that the circuit is working very close to the simulator. We can measure the deadband. The op-amp output jumps through the deadband, and it goes from 610 millivolts to minus 610 to approximately 670. Not quite symmetrical, but still we can see the feedback is now doing something useful. It's actually reduces the distortion in the output.